1.5 Angles and Measurement. Our objectives are to define and classify angles and apply the protractor postulate and the angle addition postulate. So an angle is formed when two rays have the same endpoint. So here I have some points A, B, and C. So I can say that ray BA and ray BC form an angle. Vertex, the common endpoint of the two rays that form an angle. So here point B is the vertex. Sides, the two rays that form an angle are the sides. We write an angle using 3 points, like angle ABC or angle CBA. The middle point is always the vertex, in this case, point B. Example 1. How many angles are in the picture below? Label each one 2 different ways. So we have angle XUY or angle YUX, angle YUZ or angle ZUY, and angle XUZ or angle ZUX. There are 3 different angles there, and there's 2 ways to write each one. Notice the vertex for each one is always U. Also notice the symbol that means angle here. Protractor, a measuring device that measures how open an angle is. It's measured in degrees, and we use the degree symbol here. Okay, so here is an angle red, and we measure it starting at 0, and it opens to 45 degrees. The green one starts at 0 and measures to 110 degrees. It's easy to make a mistake here. Make sure you're consistent if you're using the inside angles or the outside angles printed on your protractor to measure. Example 4, use a protractor to measure angle RST below. So grab that protractor and give it a shot, and we'll check your angle here in a second. Make sure you're putting your center point at the vertex and zeroing it out on one side, and you should see that you get 100 degrees. Next, classifying angles. Write a definition and make a sketch of the following angles. Straight angle, when an angle measures 180 degrees. The angle measure of a straight line, and it's also the rays that form this angle are opposite rays. So here's a little sketch. It's a 180 degree angle. Right angle, when an angle measures 90 degrees. So we use this symbol here that means that this is a right angle. Acute angles, angles that measure between 0 degrees and 90 degrees. So I'll call this angle X, so we can say X is greater than 0 but less than 90. Obtuse angles are angles that measure between 90 degrees and 180, so I can say X has to be greater than 90 and less than 180. Perpendicular, when two lines, segments, or rays intersect to form right angles. So here we have line AC is perpendicular to line DE. So let's take a look at marking angles and segments in a diagram. And I have 4 different examples here. We use little arcs to show when angles are the same measure. And so a 1 arc and a 2 arc would be 2 different measures. Sometimes we use a little hash mark to indicate congruence with angles, and we definitely use that notation for marking segments. So a single and a single would be congruent, a double and a double would be, but you can see that if we have a single and a double, those would not be congruent. Okay, let's apply this. Okay, example 8, interpret the picture, write all equal angle and segment statements. So we can see that segment AD is perpendicular to line FC, and that the measure of angle ADF is equal to the measure of angle ADC, which would be 90 degrees. I have a straight angle with FDC, so that would be 180. And then I know that the measure of angle ADB and BDC and FDE are all equal, so they have to be 45 because they would cut that 90 into two equal pieces. And I know that segment AD is equal to DE, and that FD equals DB equals DC because of the hash marks shown in the diagram. Okay, remember that this little symbol M and the angle means measure of angle. Angle addition postulate. The measure of an angle can be found by adding the measures of the smaller angles that are in it. Okay, so I can say that the measure of angle ADB plus the measure of angle BDC would equal the measure of angle ADC, the larger angle. So there's three angles here, two small ones and a large one. In example 9, we want to find the measure of angle QRT, which is the larger angle, and there's two smaller angles, 15 and 30 inside, so we just add them and get 45. Example 10, what is the measure of angle LMN if the measure of angle LMO is 85 and the measure of angle NMO is 53? So I'm going to label what I know, call my unknown angle X. I've written my angle addition postulate, and I've substituted what I know, and when I solve, I get the measure of angle LMN equals 32 degrees. Okay, last example. We're going to use a little algebra here. So if the measure of angle ABD is 100, and I know that the measure of angle ABC we're calling 4x plus 2, and the measure of angle CBD we're calling 3x minus 7, I can write my angle addition postulate and substitute the expressions, and then combine like terms. So I get 7x minus 5 equals 100. Now I need to solve for x. Add 5 to both sides and then divide by 7. X equals 15. So now I actually need to find the angle measures here. So I'm going to substitute 15 in for x in the expressions, and I get the measure of angle ABC is 62 degrees, and the measure of angle CBD is 38 degrees. 62 plus 38 equals 100. And I'm done. All right, I hope that works for you guys. We'll work on the practice set.